Okay, so today we're going to talk about the Rational Zero Theorem. The first thing you want to look at when you're talking the Rational Zero Theorem, or basically what the Rational Zero Theorem does, is it shows you potential roots for a function so that you can solve and find all the roots. When we do this, we look at the leading coefficient, which is 2, and the constant, which is 6. So in this case, you're going to take the 6, and you're going to put factors of 6 in the numerator over factors of 2 in the denominator. And it's always going to be the positive and negative. So let's look at this. So the fact you always take your ending constant here, that's your top, your numerator, and then you take your leading coefficient as your denominator. And in some cases, you'll see it referred to P over Q. So factors of 6 are 1, 2, 3, and 6. Factors of 2 are 1 and 2. So we're always going to have the positive and negative. Okay, so let's list them out. So we have 1 over 1 is 1. 1 over 2 is 1/2. 2 over 1 is 2. 2 over 2 is 1. We've already listed that. 3 over 1 is 3. 3 over 2 is 3/2. 6 over 1 is 6. 6 over 2 is 3. So it's going to be the positive and negative of all these numbers. So we have positive and negative 1, positive and negative 1/2, positive and negative 2, positive and negative 3, positive and negative 3/2, and positive and negative 6. So what these are potential zeros. So we need to, this is a list of zeros that could potentially work for this function that we have up here originally. However, in order to find out if they work, you have to use synthetic division. So I start with all of the positive versions. So we're going to take each positive version and divide it into the original polynomial to confirm that they work or do not work. And once we find one that works, I'll show you how to go from there. So let me get to my next page. All right, so before I do that, we're going to use 1, 1/2, and 2 to start with. So we're going to put in a 1, a 1/2, and a 2. If you go back to the original page, our leading coefficients are 2, -5, -1, and 6. 2, -5, -1, and 6. Okay, so you guys should remember synthetic division. If not, here's a little lesson on it. You bring down your first number. 1 times 2 gives me 2. Add down -3. 1 times -3 gives me -3. Add down. 1 times -4 gives me -4. Add down. This is not a factor because you have to have a remainder of 0 in order for it to be a solution, or a 0. Okay, so let's try 1/2. Same leading numbers here, same coefficients. All right, so bring down your 2. 1/2 times 2 gives me 1. Add down. 1/2 times -4 gives me -2. Add down. 1/2 times -1 gives me -1/2. Add down. This is not a solution, so nope. Nope. All right, so let's keep going. Let's try 2. Same coefficients, because we're using the same function still. Oh, that was a -1. Sorry, let me fix this real quick. That was a -1, which would make -3. Half of -3 is -1.5, which makes, hang on, let me fix this real quick. Sorry, error, 4.5. Okay, there we go. Either way, it doesn't work. All right, so -1 and 6. Bring down my 2. 2 times 2 is 4. Add, you get negative 1. Multiply, 2 times negative 1 is negative 2. Add, you get negative 3. 2 times negative 3 is negative 6. Look at there. 0 as our remainder. Yes, this works. So since we know that this works, we know that a factor now is the opposite of our root. So x minus 2 is one of our factors. And then down here at the bottom, this we came up with here, right? This is the rest of our what's left. So you drop down one level, so we were at cubed before, so now it's 2x squared minus x minus 3 is our new piece after we factor the x minus 2 out. So now to solve this, and I'll change the color to solve it, to solve this we can use factoring. So for those of you, we kind of talked about in class on Monday, the x factor. A times c, negative 6, b, negative 1. What multiplies to make negative 6 and sums to negative 1, right? So we have to divide by our, so let's do it this way. So we still have our x minus 2, and now we have x minus 3, x plus 2. Because we have a leading coefficient of 2, we have to divide each of these by 2. So we have x minus 2. This does not divide evenly, so swing up or slide. And we also have x plus 1, because 2 over 2 right here gives us 1. So there's our three factors. So now that we have the three factors, we know our solutions are going to be x equals 2. We set this equal to 0. X equals 3 halves, when we set that equal to 0, and x equals negative 1. So when you have a cubic, especially, once you find a factor like we did down here, you can use either the quadratic formula completing the square or factoring to solve what you have left, because it'll be quadratic from there. In this case, we factored. So the key is to use, and let's go back to our original sheet, use our Rational Zero Theorem to list out our potential zeros, like we did here, and then start testing them. It's a test, so I always go positive version. If I don't get one, go back to the negative version. You may have to do synthetic division repetitively to find the correct one that works, but eventually you'll find one that works. Once you find the one that works, like we did here, you can make that a factor, drop down over here by a level, and then factor by, or solve by factoring, completing the square, or the quadratic formula. I hope this helps with your review.